Hi, welcome to this video. In this, we are going to concentrate the microprocessor and microcontroller. In this microprocessor, we are going to concentrate the unit number 3, and this is the reference for this unit number 3. So, the first topic is I/O bar interfacing. So, the data transfer between microprocessor and the input device is done with the help of input port, and the data transfer between the microprocessor and output device is done with the help of output port. Now let's have a input port. It is used to read the data from the input device such as a keyboard. The simplest form of input port is a buffer. So the input device is connected to the microprocessor through the buffer is shown in this figure. So the figure shows input port. This buffer is a tri-state buffer and its output is available only when enable signal is active. When microprocessor wants to read data from the input device, the control signals from the microprocessor activates the buffer by asserting the enable input of the buffer. Once the buffer is enabled, the data from the input device is available on the data bus. So the microprocessor reads this data by initiating the read command. Next one, output port. It is used to send the data to the output device such as a display from the microprocessor. The simplest form of output port is a latch. So the output device is connected to the microprocessor through the latch is shown in this figure. Okay, when microprocessor wants to send the data to the output device, it puts the data on the data bus and activates the clock signal of the latch. So latching the data from the data bus at the output of the latch. It is then available at the output of latch for the output device. So in this section, we will see the interfacing concepts of these I/O devices and different methods. So there are interfacing techniques are I/O mapped I/O and I/O's device selections. Next, we will discuss the device selection. So in the I/O mapped I/O, the 8085 uses the I/O bar memory signal to distinguish between I/O read bar write and the memory read bar write operations. So the 8085 has separate instructions in and out for the I/O data transfer. When 8085 executes in or out instructions, it plays a device address that is a port number on the demultiplexed low order address bus as well as the higher order address bus. In other words, we will discuss the same manner in another way. We can say that higher order address bus duplicates the contents of demultiplexed low order address bus when 8085 microprocessor executes an in or out instruction. For example, the table shows if the device address is 60H, then the contents on AA15 to A0 will be as follows. Okay, so this is one instruction. Here A8 follows A0, A9 follows A1 and so on. So totally we have a 60H. Next, how to select the device. So as mentioned earlier, 8085 gives a 8-bit I/O bar address. This means it can select one of the 256 I/O port. Here we have a decoder. So to tell us, with the help of decoder, we can do some simple operations. To select the appropriate I/O device, it is necessary to do the following things. So decode the address to generate the unique signal corresponding to the device address on the bus. Next, when the device address signal and the control signal I/O bar, I/O R bar or I/O W bar both are low, so generate the device select signal. So when you focus into this, we have some idea. I/O R bar or I/O W bar. So use the device select signal to activate the interfacing device I/O port. So this figure shows the absolute decoding circuit for the I/O device. So using 74138 decoder, we will select the signal based on the input is given to the gates. Okay, and how to give the input signal means, to generate a device select signal Y0 low, the address on the address bus must be the given below, that is A0, A1, A2 is equal to 000H. So I automatically activates Y0 output. When you go for A6, that is A3 to A6, 0000H, that is all the things are 0, makes G1 and G2. So that is this one, makes G1 and G2 low to enable the output of decoder. Next one, when A7 equal to 1H, makes G high to enable the output of the decoder. That is when your A7 is equal to 1, automatically it will enable the output of the decoder. In this manner, so the decoder output is enabled only when control signal G1 and G2 are low and the control signal G is high. Therefore, the address of this IO device 80H is shown in this table. So this is IO bar interfacing. So thank you.